Hey everyone, and welcome back to another explainer, proudly brought to you by Forge College. I am absolutely stoked to be diving into this with you today. You know, if you've been following along, we've really been deep in the trenches, meticulously building our modular smart contract capstone project, piece by piece. Well, guess what? Today is the day. We are officially initiating the ultimate pre-flight launch sequence. So grab your safety helmets, buckle in, because we are prepping for final integration, testing, and delivery. Let's get into it. Just to anchor ourselves in the curriculum timeline real quick, look at how far we've actually come. We kicked things off with Solidity from zero. We wrestled with the complexities of inheritance and interfaces, and then we tackled the capstone project design. In our last mission, we ran rigorous integration testing and security checks, basically hunting for any tiny cracks in the hull. So today, sitting here at point 4, it's all about bolting those final pieces together for liftoff. This is exactly where all that hard work becomes a fully packaged reality.
All right, here's our flight plan for today's explainer. First, gathering artifacts. Second, acceptance criteria. Third, the 7-step workflow. Fourth, final checkpoints. And lastly, delivering your masterpiece. We're going to cover exactly how to assemble, test, and box up these modules without, any unexpected explosions on the launch pad.
Okay, moving right into Phase 1, gathering your artifacts. Let's bring our meticulously crafted parts out of the hangar.
So, what exactly are we bringing to the assembly bay? First up, we've got our interface definitions, things like IRegistry and IPaymentRouter. These are absolutely crucial, guys. Having stable, concrete interface shapes is what ensures our gears mesh perfectly, with literally no friction whatsoever. Next, we add our implemented core modules, our freshly generated integration test reports, and those super vital load testing impact nodes. Keep in mind, we're not actually writing new logic today. Nope, we are simply synthesizing the brilliance we've already created into one cohesive package.
Which brings us to Phase 2, the acceptance criteria. Let's look at the rigorous engineering specs we need before we can hit the launch button. Notice how every single criterion on the left has to be paired with a very concrete verification method on the right. Like, if we claim the project compiles, we need a totally clean log from a Hardhat compile or a Forge build. Saying the tests pass will show me the full test report with 0 failing cases. Our architecture has to match our documented design with a clear README mapping, test artifacts got to be present in the config, and dev docs need to be completely readable. Basically, every single claim requires hard evidence so reviewers can easily verify our work. And that is why this exceptions checklist is absolutely our definitive baseline. It's really all about ensuring total transparency between us and the reviewer. Look, plans change, and that's totally fine, but any intentional deviations from our original design, they have to be explicitly justified in the changelog. Sneaking undocumented changes into the codebase is honestly like hiding a stray wrench inside a rocket engine. It's definitely going to trigger massive alarms during the review process.
All right, let's get into Phase 3, the 7-step workflow. It's time to fire up the actual pre-flight launch sequence. Okay, you're going to execute these directly from the root directory. Step 1 is our sanity compile. Think of it as our static fire test. Run your compile command to catch any super obvious typos or missing brackets. Step 2 is firing up the full integration test suite. I highly recommend using a bail flag here to just stop the presses at the very first sign of trouble. Now, Step 3 is where it gets kind of fun. We expand our suite by adding 2 brand new failure mode tests to cover any edge cases we spotted earlier. And Step 4, run or trigger your continuous integration pipeline. We need to make sure the server environment perfectly matches our local results.
To actually see Step 3 in practice, just imagine writing a cross-module interaction test. We want to explicitly test that our payment router completely rejects routing to unregistered modules. We want it to revert with a module not registered message. Because honestly, we definitely do not want our payment router getting confused and accidentally ejecting our users' funds out into the void to some random unregistered address, right? We literally test for failure specifically so we can guarantee success.
Okay, let's round out the sequence with steps 5, 6, and 7. Step 5 is writing up the flight manuals, packaging your developer docs, updating the README, and finalizing that changelog we talked about. Step 6 is packing the cargo. You're going to bundle everything up into a compressed tar file so it's neatly boxed up and ready for delivery. And finally, Step 7. This is running one last, completely clean verification on a fresh local node. This proves the project actually works out in the wild, not just on our specific, perfectly configured laptops.
Moving right along to Phase 4, the final checkpoints. These are the last 4 system checks before we hand over the keys.
Just look at the stark contrast here. On the left, we have success, that beautiful, glorious output saying compilation finished successfully and 0 failing tests. It's literally what every developer dreams of seeing. But on the right, we have failure, remediation. If we see anomalies, we don't panic. Actually, scratch that. No one panics. We just fix the top error first. We run an isolated test on a fresh node. More often than not, the culprit is simply a mismatched interface signature between modules. It's kind of like trying to force a 3-prong plug into a 2-pronged outlet. You just have to troubleshoot systematically, one error at a time.
So, to quickly summarize, here are our 4 non-negotiable checkpoints. Check 1, compile success, meaning absolutely 0 errors. Check 2, all integration tests pass. Check 3, interface stability. This means absolutely no hidden public functions sneaking around that aren't properly documented in our interfaces. And check 4, artifact presence. Do we actually have the logs and the files? This is our ultimate go or no-go decision, guys. If these 4 are totally green, we are officially cleared for launch.
And finally, Phase 5, delivering your masterpiece. Let's take a step back and look at the overall engineering philosophy. There's a golden rule we really need to internalize here. Treat interfaces as contracts between teams. Let integration tests be the canonical record of cross-module behavior. This is the absolute bedrock of modular smart contract design. Code comments are great, but let's be real, they get outdated fast. Tests are executable, they are verifiable, and they serve as the true, unarguable source of truth for exactly how our modules interact.
So as we put the final bow on this project, keep these 3 major practical takeaways in mind. First, design to code traceability. Your README map should let any reviewer validate the architecture without having to dig through every single line of code. Second, treat your tests as executable documentation. And third, aim for reproducible packaging, so a reviewer anywhere in the world can easily replicate your success. If you do this, your codebase isn't just some random script, it is a highly maintainable, easily verifiable masterpiece.
All right, so now that we have this perfectly packaged deliverable, what exactly happens next? Well, in our upcoming mission, we'll be pivoting to the fundamentals of Ether in smart contracts and applied Solidity development. And honestly, here's the best part. This beautifully integrated capstone project we just wrapped up, it's going to serve as the verified baseline for exploring gas-aware design and runtime behavior. We've built an incredible foundation here.
As we wrap up this explainer, I want to leave you with a bit of a provocative question to chew on. What assumptions in your cross-module design cause the most friction? Really think about it, learn from it, and hey, make sure to record it in your changelog. Thank you so much for joining me on this launch sequence. Remember, this explainer was proudly made by Forge College. If you want to dive deeper into this subject or explore a whole galaxy of other Web3 topics, make absolutely sure you visit forge.college. Keep building, stay curious, and I'll catch you in the next one.